Welcome to AI Frontiers, where we explore the cutting edge of artificial intelligence research. Today, we're diving into machine learning frontiers, privacy, forgetting, and multimodal intelligence. We'll examine 17 groundbreaking papers from November 17, 2025, spanning revolutionary advances from surgical memory deletion in AI systems to real-time medical prediction algorithms. Join us as we uncover how researchers are fundamentally rethinking privacy-preserving AI, graph-based intelligence, and multimodal systems that process the complexity of real-world information. Picture this. While you're listening to this very sentence, somewhere in the world, a machine learning algorithm is quietly learning to forget. Not just any forgetting, but surgical, precise forgetting that can remove specific memories from an AI's mind without damaging everything else it knows. It's like performing brain surgery on a digital mind, extracting unwanted memories while leaving the patient's personality intact. This isn't science fiction. It's happening in research labs right now, representing the frontier of privacy-preserving artificial intelligence. Algorithms are developing the capability to selectively erase information with unprecedented precision, opening new possibilities for data protection and model adaptation. Today's research journey takes us through 17 papers that address some of AI's most pressing challenges. We're not discussing incremental improvements, but fundamental rethinks of how AI systems should work, learn, and interact with the world. From selective memory erasure techniques that can forget specific data points while preserving overall knowledge, to real-time medical prediction systems achieving sub-millimeter accuracy, these papers showcase remarkable diversity. We'll explore theoretical breakthroughs that challenge common assumptions about large language models, alongside practical innovations making AI more efficient, secure, and deployable in resource-constrained environments. Each paper represents a piece of the larger puzzle of building trustworthy, capable artificial intelligence. To understand today's research significance, imagine machine learning as a vast digital metropolis. In this sprawling city, different neighborhoods specialize in different types of intelligence. Deep neural networks, tower-like downtown skyscrapers, processing massive amounts of data with their layered architectures. Traditional algorithms occupy suburban optimization neighborhoods, quietly solving mathematical problems and making predictions. In the research quarters, experimental algorithms test innovative ideas that might transform the entire city. Computer science machine learning, known as CSLG, represents the architectural planning and urban development of this digital metropolis. It designs infrastructure, establishes principles, and pushes boundaries of what's possible in artificial intelligence, sitting at the fascinating intersection of mathematics, computer science, and cognitive science. Our first major theme revolves around privacy, preserving intelligence, and the fascinating challenge of machine unlearning. Imagine trying to perform selective amnesia on a human brain, removing specific memories while leaving everything else intact. This is essentially what machine unlearning attempts with artificial neural networks. As AI systems handle increasingly sensitive data, the ability to remove specific information from trained models becomes crucial. Think of it as digital privacy surgery, where algorithms can forget specific data points while maintaining their overall knowledge and capabilities. This theme reflects growing understanding that privacy isn't just about protecting data during collection, but maintaining privacy throughout the entire lifecycle of AI systems, from training through deployment and beyond. The second theme focuses on graph-based network intelligence, representing a fundamental shift in how we process information. Traditional machine learning treats data points as isolated islands, analyzing each piece of information independently. Graph-based learning recognizes that most real-world data exists in rich webs of relationships. Picture a social network where understanding any individual requires understanding their connections, or a molecular structure where each atom's behavior depends on its bonds with neighbors. Graph neural networks and related approaches are revolutionizing how we handle relational data, from predicting protein structures to optimizing transportation networks. This theme represents evolution from treating data points independently to embracing the interconnected nature of real-world information, enabling more sophisticated and contextually aware AI systems. Our third theme centers on efficiency and practical deployment, addressing the critical challenge of making powerful AI work in resource-constrained environments. As AI models grow larger and more sophisticated, deploying them in real-world environments becomes increasingly challenging. Think of it like trying to fit a massive symphony orchestra into a small jazz club. You need creative solutions to maintain performance quality while working within practical constraints. Researchers are developing innovative compression techniques, quantization methods, and architectural optimizations that make powerful AI accessible on everything from smartphones to embedded systems. This theme reflects the field's maturation from research prototypes to practical systems that must operate efficiently in the real world, democratizing access to advanced AI capabilities. Now, let me share 6 game-changing discoveries from today's research that fundamentally challenge our assumptions and open entirely new research directions. First, machine unlearning has achieved the seemingly impossible. AI systems can effectively forget specific information using only 5% of their original training data, performing memory-selective amnesia with surgical precision. Second, sparse computing has achieved 1.5 times memory reduction, coupled with 1.2 to 1.5 times speedup over dense representations, making large language models practical for resource-constrained deployment. Third, medical AI has reached sub-millimeter accuracy within 0.2 millimeters, with a 4,000-fold speedup over conventional simulations, enabling real-time precision during breast cancer biopsy procedures. Fourth, researchers revealed that large language models exhibit up to 30% inconsistency in belief updating when presented with new evidence. Fifth, experimental constraints have been successfully integrated into protein design models for the first time. These breakthroughs represent fundamental advances, rather than incremental improvements. Today's paper of the day exemplifies innovative thinking driving the field forward. Uncovering and Mitigating Transient Blindness in Multimodal Model Editing by Xiaoqi Han and colleagues addresses a critical but previously unrecognized problem in AI systems that process multiple types of information simultaneously. Picture this scenario. You have an AI system analyzing both text and images to answer questions. It works perfectly, understanding complex relationships between visual and textual information. But when you correct some factual error in its knowledge base, something subtle and dangerous happens. The system becomes partially blind to visual information, even when that visual information is crucial for making correct decisions. This phenomenon, which the researchers named transient blindness, is like a person who, after focusing intensely on reading, temporarily loses the ability to process visual cues around them. The discovery emerged from developing more rigorous evaluation frameworks that revealed this hidden flaw in multimodal AI systems. The human story behind this discovery adds compelling context to the research. Lead researcher Xiaoqi Han was initially working on improving standard model editing techniques when she noticed something odd in the results. The edited models were performing well on standard benchmarks, but when tested on more realistic scenarios requiring both visual and textual understanding, they were failing in subtle but systematic ways. This observation led to months of investigation that ultimately revealed the transient blindness phenomenon. Traditional evaluation methods, borrowed from text-only model editing research, were giving misleadingly positive results because they relied on test cases too dissimilar from edited content, or used random inputs that didn't properly test multimodal integration capabilities. Her persistence in investigating these anomalous results led to a fundamental rethinking of how we evaluate and maintain multimodal AI systems. The team's solution is as elegant as their discovery was surprising. They developed locality-aware adversarial losses that explicitly work to maintain balance between different types of information during the editing process. Think of it as training the AI system to maintain its peripheral vision while focusing on specific corrections. The adversarial component creates a kind of internal debate within the system, forcing it to maintain its multimodal reasoning capabilities while incorporating necessary corrections. This represents systems-level thinking for understanding how different components of complex AI systems interact and influence each other. The work also demonstrates the importance of developing evaluation methods that reflect real-world usage patterns. By moving beyond traditional benchmarks to more realistic testing scenarios, the researchers uncovered a problem that had been hiding in plain sight. This methodological contribution may prove as important as the specific technical solution they developed. Looking toward the future, today's research landscape points towards several exciting directions that could fundamentally transform artificial intelligence. Think of the current moment as standing at the edge of a vast digital frontier, with multiple pathways stretching toward horizons we can barely imagine. The convergence of privacy-preserving techniques with practical deployment needs suggests we're moving toward AI systems that can be both powerful and trustworthy. Imagine AI assistants that can learn from your personal data to provide better service while mathematically guaranteeing that your private information remains protected. Theoretical breakthroughs in understanding large language models point toward a more mature and scientifically grounded approach to AI development. Rather than simply scaling models larger and hoping for emergent capabilities, we're developing principled understanding of what these systems can and cannot do. The integration of multimodal learning with robust evaluation methods suggests we're approaching AI systems that can handle the full complexity of real-world environments. Understanding rich relationships between different types of information, much like human intelligence does. As we conclude today's journey through machine learning research frontiers, we've seen how the field simultaneously addresses fundamental theoretical questions and practical deployment challenges. From algorithms that can selectively forget to systems predicting medical emergencies in real time, from theoretical frameworks revealing large language model limits to practical innovations, making AI more efficient and secure, the research demonstrates a field in remarkable transformation. The 17 papers we've examined represent more than technical advances. They represent a community of researchers working to ensure artificial intelligence develops in ways that are beneficial, reliable, and aligned with human values. Whether developing privacy-preserving techniques, creating more interpretable systems, or building AI that handles real-world complexity, these researchers are laying the foundation for a future where artificial intelligence amplifies human capability rather than replacing it. The discoveries will influence AI development for years to come, representing the careful, thoughtful research essential for building trustworthy AI systems. This analysis was created using AI synthesis with Claude Sonnet 4202-50514 for content analysis, TTS synthesis powered by Deepgram technology, and image generation capabilities through OpenAI systems. Human expert review was conducted on all synthesized content to ensure accuracy and clarity. However, we acknowledge that some oversights may exist despite this review process. The goal is to make cutting-edge research accessible while maintaining scientific rigor and acknowledging the collaborative nature of modern research communication. We strive to present complex technical concepts in an engaging, understandable format while preserving the essential insights and implications of the original research. This approach reflects our commitment to democratizing access to advanced AI research while respecting the work of the original researchers and the scientific community. Thank you for joining us on AI Frontiers, your gateway to cutting-edge research. Subscribe to our podcast for weekly deep dives into the latest breakthroughs shaping artificial intelligence. Explore the open access papers we've discussed today and join the conversation with colleagues and fellow AI enthusiasts. Share your insights about these developments and help shape the broader discussion about AI's future role in society. Next episode brings more cutting-edge AI research discoveries as we continue exploring the innovations that will transform tomorrow's technology. Keep learning, questioning, and pushing the boundaries of what's possible. In this podcast, we bring you the latest breakthroughs in computer science and AI, straight from archive preprint server. From neural networks to quantum computing, we simplify complex research so you can stay ahead. Whether you're a developer, researcher, or tech enthusiast, AI Frontiers keeps you informed daily. Thanks for listening. If you enjoyed this episode, subscribe for daily updates. See you tomorrow with more cutting-edge AI insights. Disclaimer: this video uses archive-preprintserver.org, content under its API terms of use. AI Frontiers is not affiliated with or endorsed by archive-preprintserver.org.